Bright Tuty. Every student matters.
Hello students. Now I'm going to start with inverse proportion in this session, as we have already discussed direct proportions and we have practiced questions also on direct proportion. Let us start with inverse proportions. So I give you a brief idea about what is inverse proportion. So I told you that whenever we have an increase in some quantity, in one quantity, that will cause a decrease in the second quantity and vice versa. So when this kind of relationship is there, we call that the quantities are inversely proportional, not directly proportional. So here is speed given and here is time given. So when we increase the speed, the time taken to cover the distance is definitely less, right? So when you increase the speed, the time taken decreases. Whenever we decrease the speed, time taken to cover the distance increases. So you see, decrease in one causes increase in another, right? Or increase in one causes decrease in another. This kind of relationship is known as, or the quantities are said to be in inversely proportional. So here is an example, just see. For walking, if the speed is 3 km per hour, the time taken is 30. Now for running, when the speed is 6 km per hour, then so we have done what, 3 multiplied with 2. So here also 30, we are now taking, we have increased the speed, so time will be half, that is just see 15 minutes. Now for cycling, we are making the speed go 3 times, so the time will be 1 upon 3, right? That means they are increasing in or decreasing in proportions. When speed is 45, you multiply 3 with 15, right? So the time taken is 30 into 1 upon 15, that is 2 minutes. Clear? So this is how we have expressed here. In the previous session you have learned, when we are multiplying this with 2, the second also was getting multiplied with 2. That was directly proportional case, but here increase in the speed decreases the time taken. So here we are doing the reciprocal of that number and multiplying it. So this is known as inverse proportion. Clear? So what we can see here from here, if two quantities x and y are said to be in inverse proportion, as in this case, suppose this is x and this is y, they are in inverse proportion, then if there exists a relationship of the type xy equal to k. Why are we saying this? Just to see, if you multiply x and y, 30 into 3 is 90, 15 into 6 is 90, 9 into 10 90, 45 into 10 90. So all the multiplication for x and y, it is going to give us the same answer, the same constant number, and this is represented by k. So in direct proportion we were having the relationship x upon y equals k, but in inverse proportion we will have x into y equals k. Clear? This is how we say that when we multiply x and y, we get the constant of proportionality. So now it is written here that k being a constant, y1 and y2 are the values of y corresponding to the values of x1 and x2 of x respectively, then x1 upon y, x1 into y1 is equal to x2 y2, right? Or we can say this, how we can say this, just see the same example. Here if I write 3 into 30 is equal to 6 into 15. Yes, they both are 90. So I can consider this as x1, this is y1, this is x2, this is y2. So what we have done, x1 is multiplied with y1, right? x2 is multiplied, x1 is multiplied with y1, x2 is multiplied with y2. Correct? So we actually got x1 y1 is equal to x2 y2. This is what they are saying in the definition, right? Or we can write x1 y1 equal to x2 y2. Keep the terms of x on one side, so this will come in denominator, and here we will have y2 upon y1. Here it is not y1 upon y2. Keep this in mind, it is y2 upon y1, right? So we can use this to find out the other values that are asked in the table. So this is what inverse proportion is. Now if you see here, there are 3 tables given. The data in tabular form is given to us. They're asking, observe the following tables and find which pair of variables, here x and y, like the variables here are x and y, are in inverse proportion. We have to check. If they are in inverse proportion, then xy should give us the same value, that is k. K can be any number. So let us check for the first one. 50 into 5. X into y should be k. So the first one, if we multiply x1 y1, 50 into 5, first one will give us how much? 5 5s are 25. 250 is the value for k in the first one. Second one, you see 6 4s are 24. Second value is 240. So is it same? No. So this one is, the answer is no. The first one is not in inverse proportion. Here x and y are not in inverse proportion. Let us check for the second one. For the second, if we check, just multiply. 60 into 100 gives us 6000. 30 into 200, 3 2s are 6, yes, 6000 we get. 300 into 20, yes, it gives us 6000. And 15 4s are 60 and zeros. So yes, we are getting every time the value of k, which can be calculated by multiplying x and y. So yes, we are getting it as k. Clear? So it is same. There is a constant value that we are getting. So yes, this is a case of inverse proportion. Here the variables x and y are in inverse proportion. Now the third one. Here if we try, 90 into 10 gives us 900. 50 into 60. 15 into 6 is 90. 900 we get. 45 into 20 is also 900. Right? 25 into 3 is 25 3s are 75 and 0. So 750 we are getting. So do you see, is it same? No. Just to 3 values it is same, and then it is changing. Right? Also here we are getting 600, right? So every time we're getting here then different values. So this is not a case of inverse proportion, or we say the variables x and y are not in inverse proportion. So the answer is no here. I hope this gives you some idea about how to check for inverse proportion. Moving ahead. So here is something that you need to really take care of. When two quantities x and y are in direct proportion, or we say they vary directly, they are also written as x directly proportional to y, right? So this is a case of direct. And when two quantities are in inverse proportion, or we say they vary inversely, then they are also written as x inversely proportional to y. When we remove this sign, we equate it, we remove this sign, we make it as equal to sign, and instead of this we write ky. So we say x upon y is equal to k. Right? We have used this relationship only for direct variation or directly proportional. Inverse, we will write it as k upon y. That gives us xy equals k. This is the relationship for inverse proportion that we will use. Right? So these are the two things you need to keep in mind. So whenever it is written like this, you don't have to worry about it. Is a case of directly proportional. This is a case of inversely proportional. The reason is increase in x or increase in y gives a corresponding increase in another variable, right? But here when y is increasing, right, this number will become smaller, so x is decreasing there. If y is decreasing, x is increasing. That means inverse proportion. Okay. Now here we have one question. So think about it and understand it carefully. It says 6 pipes are required to fill a tank in 1 hour 20 minutes, right? So what we have been given? We have been given number of pipes and we have been given the time. Okay, so 6 pipes are there. Then to fill the tank, the time required is 1 hour 20 minutes. That means total minutes is 80 minutes. Okay, in minutes I am mentioning it. Now they are saying if how long will it take? So we have to calculate the time. Let it consider as y1. How long will it take if only 5 pipes of the same type are used? We are using 5 pipes instead of 6 pipes. So because we know, see, when there are number of pipes, 6 pipes are there, so the time taken is less. The tank will get filled up in lesser time. When the number of pipes is less, that means 5 pipes, so the tank will take more time to fill the tank, right? So this is inverse proportion. So we'll multiply 6 with 80 and 5 with y1. So we get y1 as equal to 6 into 80 upon 5. 5 ones are 5, right? 3 is left, 5 6 are 30. So y1 is equal to 16 into 6, that is 6 6 are 36, 6 ones are 6 and 3 is 9. So 96. How many minutes will it take? It will take 96 minutes instead of 80 minutes. So the time required is more in this case because the number of pipes is lesser now. Okay. Moving ahead, we have another question. It says there are total 100 students. Okay. Food provision for them is for 20 days. 100 student and the food provision is for 20 days. So we will write students So how many students? 100 students. And food provision is for how many days? We will write here days. It is for 20 days. Now they are saying how long will these provisions last if 25 more students join the group. If 25 more joins the group, then the number of students will be 125, and we have to calculate this, that how many more how many days will it last. So definitely, when more students are there, so the food will be used more, it will be eaten by them, a large quantity would be eaten, because now there are 125 instead of 100, so the number of days that it will last is going to be lesser. So 100 into 20 is equal to 125 into y1, as this is a case of inverse proportion. So we get 100 into 20 upon 125 equals y1. 25 we can cancel definitely. 25 fours are 100, 25 fives are 125, 5 ones are 5 fours are. So y1 is going to be 16. So instead of 20 days, it will just last for 16 days, because now there are 125 students who will be utilizing the food instead of 100 students. Okay. Moving ahead, here is another good question. It says 15 workers can build a wall in 48 hours. So we have workers and we have time taken to build the wall. So for 15 workers, it takes 48 hours to build a wall, and we have been given 30 hours. Okay, in 30 hours, how many workers we require, okay, to do the same work, if that has to be completed in 30 hours? Definitely, when time is less, you require more people, right? If I want some task to be completed first, I would like more people to do it simultaneously, so that everybody is doing a little bit of work and it gets completed in lesser time. Okay, so because it is inverse proportion, we'll multiply it. Right, 15 into 48 upon 30 equals x1. 15 ones are 15 twos are 30, 2 ones are 2 twos are 4, 2 fours are 8. So we get x1 as 24. So we require 24 workers instead of 15 if we want the same work to be completed in 30 hours. Is that clear? So see, these are real life situations that we really face, right? And we can actually come to know how many workers, how much time will it take. So we can do these analysis using this concept.